I bet you didn't know your phone could secretly learn a hidden layout of images. That's the latent space. VAEs are the map makers. Start simple. A VAE is a generative model. It learns to squash data into a compact code, then reconstruct it, like zipping and unzipping pictures. The encoder turns inputs into two things: a mean for each latent dimension, a variance for each latent dimension. From that distribution, we sample a point. That's the secret sauce that gives VAEs their creativity. To train smoothly, we use the reparameterization trick. We sample noise, then shift and scale it with the mean and variance so gradients can flow. The decoder takes that sampled code and rebuilds the original data. Sometimes perfectly, sometimes with new twists. Training balances two goals: reconstruction loss, make outputs like inputs, KL-divergence term, nudge the latent space toward a Gaussian so it's smooth and generative. Why care? VAEs can generate realistic images. They can fill in missing data and reduce dimensions while keeping uncertainty. Variants like conditional VAEs, VAE-GANs, extend control and sharpness. Recap. Encoder parameterized latent distribution sample decoder trained with reconstruction loss and KL loss. Simple idea, powerful results, creative, probabilistic, and surprisingly useful.